going down in the DM. What are we looking at? We're trying to find out whether or not a series converges, and more specifically, absolutely. But absolute convergence implies convergence, so why don't we go after that first? So we check absolute convergence, and you're like, how? Well, we slap the absolute values on it. Absolutely. So if I take a look at that series with absolute values on it, then I'm testing it for absolute convergence. Absolutely. We take a look at the absolute value, and absolute values do what absolute values do, and that absolutely gets rid of the alternating part. And then we can get rid of our absolute values because the inverse tangent, that tank, is bigger than 0 when k is bigger than 0. Similarly, the denominator k to the third, well, there is no disagreement there. That's bigger than 0 when k is bigger than 0. So now we need to choose a direction. Choose a direction. Which way do you think it's going to go? Do you think it's going to converge, or do you think it's going to diverge? So here we're picking a direction, and when you look at something like that, you're like, oh no! What are you going to do? But then you say, hey, wait, what does that look like? What does that look like? That looks like the inverse tangent to the k. What part bothers you? It's that tank that bothers you. So make it explode. That's going to be bigger than or equal to pi over 2 divided by k to the third. Because why? The inverse tangent is bounded above by that guy. So the tangent inverse is bounded above by pi over 2, so that expression is true. And then what? We're going to use the comparison test because we're looking at that series. Yeah, all right, that's the same series as I can pass a constant out. I did it. And now I look in it. In it, I see Snapchat me that p-series. That is a convergent p-series. So by the what test? The comparison test. Our original series is convergent, but not just convergent, absolutely convergent.